Good morning, children. Today we have got the discussion of 30 questions from physics, paper number 5, Newton's laws or laws of motion. First question. A plank with a box on it at one end is gradually raised from the other end. As the angle of inclination increases with respect to the horizontal, and when that angle reaches 30 degree, the box just start to slip. Okay, we know that angle is called angle of repose. Angle of repose is nothing but angle of friction. Angle of repose is equal to angle of friction. And we know the equation for coefficient of static friction, mu s is equal to tan of angle of friction. Okay, here angle of friction must be then 30 degrees. So tan 30 is 1 by root 3. Then the coefficient of static friction will be tan inverse 1 by root 3. That angle is 30 degree, so that we can get tan 30 as 1 by root 3. 1 by root 3, when you calculate, you get 0.6. But there are two options, 0.6 and 0.6 and also 0.6 and 0.5. We have to go for option 3 because coefficient of static friction and coefficient of kinetic friction are not same. Kinetic coefficient is slightly less. Also, you can justify your answer by using this equation. You can find out the acceleration at first by using the kinematic equation. S is equal to ut plus half at square. As it starts from rest, u is 0. So distance traveled is 4 meter, half times. Acceleration along the plane is a times t square. T is 4 seconds, it is given 4 square. From this you get 4 by 16, that is by 2. When comes here, cancel this one, you get 0.5, right? Acceleration is 0.5 meter per second square. Now acceleration is there, it is a rough inclined plane. You can have the formula for acceleration, net force divided by mass. Acceleration is nothing but net force. Net force is mg sin theta acting down the plane minus mu times kinetic friction, mu times normal reaction, where mu is the kinetic coefficient. Normal reaction on inclined plane, as you know, is mg cos theta. This is the net force. Mg sin theta is acting downward, component of mg acting down the plane, that is mg sin theta minus kinetic friction. Kinetic friction is mu k times normal reaction. Mu k is coefficient of kinetic friction. Normal force on inclined plane is mg cos theta. Okay, divided by mass. Okay, now you can substitute for acceleration, which is 0.5. Then you can cancel this mass m. Theta is known to you. G is taken as 10. You can find out the value of mu k and you can justify your answer as to be option 3. Okay. Now, second one. Two masses of m and 2m are whirled in horizontal circles. The heavier one in a radius r by 2 and in the lighter one radius r. So two horizontal circles. Two horizontal circles like this. The mass m and 2m. Heavier one in radius r by 2. So this is r by 2. That is heavier one. Heavier one means 2m. The other one is m. Its radius is r. The radius of the lighter one is r. The tangential speed of lighter one is n times that of value of heavier stone. Then they experience same centripetal forces. The value of n is, that's the question. Same centripetal force. Formula for centripetal force, m v square divided by r. Okay, for heavier one, mass is 2m. Okay, heavier one has its radius r by 2. What is the speed of heavier one? It is given that tangential speed of lighter stone, that is 2m, m, that is equal to n times the tangential speed of heavier one. So here I have used heavier one, 2m, into v square, where v is the speed of the heavier one, that is v2m. Okay, right? V suffix 2m square divided by r by 2, that is equal to. What about the lighter one? Lighter one is of mass m. What is the speed of lighter one? That is Vm square divided by, what is the radius of lighter one? Is r. So you can take this r from the denominator to the numerator, and that r will come here. Okay, that is 2 into 2m divided by r into V2m square is equal to m by r multiplied by Vm square. What is Vm square? That is n square V2m whole square. Okay, so V2m whole square gets cancelled, m gets cancelled, r gets cancelled, so that you get n square equal to 4 and n is equal to 2. So the right choice is option B. Next one, a rigid ball of mass m strikes a rigid wall at 60 degree and gets reflected without any loss of the speed as shown in the figure. Value of impulse imparted by the wall on the ball. Impulse is equal to change in momentum. That is impulse momentum theorem. Impulse is equal to change in momentum. Okay. Here, resolving this initial momentum into two rectangular components. As this angle is 60 degree, this angle is also 60 degree, so that this one is mv cos 60 and the other one is mv sin 60. At the same time, you resolve this one. One component is the cosine component, which is parallel component, that remains same, mv sin 60. The other component, while reflection, becomes minus mv cos 60 because the direction has been reversed. Okay, change in momentum along vertical direction is 0 because mv sin 60 downward, here also mv sin 60 downward. So the vertical direction there is no change in momentum, but horizontal direction the momentum has been reversed without any change in its magnitude, because it is given that there is no loss of the speed, so momentum has same magnitude on reflection. So mv cos 60 and minus mv cos 60. So what is that change? That change is numerically mv cos 60 minus mv cos 60. That is 2mv multiplied by cos 60. Cos 60 is 1 by 2. So impulse is equal to change in momentum. So the answer is mv. Fourth one. One end of the string is connected to a particle of mass m and other end is connected to a small peg on a smooth horizontal surface. Table, particle moves in a circle with a speed v. The net force on the particle, which is directed towards the center, will be, T represents the tension. Okay, it's all about a horizontal circle. It's all about a horizontal circle. There is a string and also there is a mass. Various forces are tension T, radially inward, centrifugal force mv square by L, where L is its length. Okay, as the mass is kept on a frictionless horizontal surface, the weight mg is balanced by the normal contact force. So N is equal to mg. Here horizontal forces balanced, T is equal to mv square by L. So as T is equal to mv square by L, we may think that the net force is 0. That is incorrect. It is not 0 because it changes direction. The tension is the necessary centripetal force which changes the direction. So what is the net force? Net force is equal to mass times acceleration. As it is uniform circular motion, there is only one acceleration component, that is the radial component called centripetal acceleration. So m times. What is the formula for centripetal acceleration? That is v square by L. But mv square by L is nothing but a T. So our correct answer is option first one. So tension is the net force acting on this body which is directed towards the center. Centripetal force is also the tension. What is centrifugal force? mv square by L. You just find what is you getting for mv square by L. Here when you calculated, we substituted, we got mv square by L as to be tension. So centripetal force is tension, net force is tension, which is directed towards the center. Next one, two blocks A and B, masses 3m and m respectively, connected by a massless inextensible string. The whole system is suspended by a massless spring as shown in figure. The magnitudes of acceleration of A and B immediately after the string is cut are respectively. Immediately after the string is cut, this is the string. When the string is cut, what happens? You know, the spring is already elongated, extended by the weight 3m plus m, that is 4m. Okay. Now, what happens? On cutting, B falls downward because string has been broken. B falls downward freely. So, acceleration of B will be G. So, A and B respectively. So, acceleration of B is G. So, it is not correct. This is also not correct. So, answer 2 or 3. Both will not have same acceleration. Okay, we cannot conclude like that and go to answer 2. Let us try how to get that. At the beginning, what is the equation for net force? Equation for net force at the beginning. At the beginning, 3m plus 4m, 3m plus m, that is 4m is acting downward. That is 4 mg, weight of 4m mass is acting downward, which is equal to kx. Okay, that is 4 mg equal to kx. So kx is 4 mg. Next time, when it is broken, what is that force? That upward force is kx, because x was the extended length, x was the extension when at the moment when it was cut. So kx is acting upward. Okay, what is the downward force? What is the mass of that one? That is 3m. So 3m into g is acting downward, and this mg is lost. Okay, now what is the net force? It is accelerating upward. What is the net force? Net force is kx minus 3mg. That is equal to mass times acceleration. What's its mass? Its mass is 3m times acceleration. But what is kx? Already we have found kx is 4mg. That is 4mg minus 3mg equal to 3m into a. That is mg equal to 3ma. So m cancels and a is equal to g by 3. So the correct answer is option 2. Okay, easy method for the second part. Okay, net force is equal to the left force. What is the left force? Left force is mg. Left force divided by mass will be the acceleration. Left force is mg. mg divided by 3m. So you get g by 3. Okay, you try like that. That is an easy method. Sixth one. Which of the following statement is incorrect? These type of questions are very important for NEET. Frictional force opposes relative motion. Frictional force opposes relative motion or impending motion. That is true. Limiting value of static friction is directly proportional to normal force. That is also true. Limiting friction is equal to mu s times normal contact force. Third one, rolling friction is smaller. Yes, rolling friction is smaller in magnitude than similar situations sliding friction. So third one also it can be correct. Fourth one, coefficient of sliding friction has dimensions of length. Coefficient of sliding friction does not have any dimensions like coefficient of static friction, but coefficient of rolling friction has the dimensions of length. So here the incorrect statement is option 4. So that is the right answer. A block of mass m is placed on a smooth wedge ABC. It is smooth, important. Inclination theta. Wedge is given an acceleration a towards right. The relative relation between a and theta for block to remain stationary. For this block to remain stationary, let us find out what are the forces acting on the block. The block is acted upon by mg sine theta down the plane. Okay. Now, the block is to be at rest. For that, one more force should be acting in the upward direction. We have to find out that force. Okay. When this wedge is given a horizontal acceleration, the block is acted upon by a force that is mass of the block times its acceleration. Okay, as this angle is also theta. This component of that MA is MA cos theta. Now for equilibrium, it must be MA cos theta is equal to mg sin theta. M gets cancelled and A is equal to g tan theta. So A is equal to g tan theta is the right answer. Block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. Coefficient of friction is 0.1. Minimum angular speed so that the block is stationary while the cylinder is rotating about the vertical axis. So this is the case where the cylinder is rotating about this axis like this. Okay, we have to find out the minimum angular velocity. Let omega be the minimum angular velocity with which the cylinder is rotating so that a block of mass 10 kilogram is held stationary. Its mass is 10 kilogram. Okay, let that be the mass m. Now, what all are the forces acting over this case? mg is acting downward. Now, for holding it fixed there, frictional force should be acting in the upward direction because the tendency of the block is to slide down. Frictional force is against the impending motion. Impending motion means a tendency to slide. The tendency to slide is downward. So static friction is acting upward. The maximum value of static friction is the limiting friction. That is the limiting case. Now one more force, that is the centrifugal force, which is acting radially outward. I am writing centrifugal force in terms of omega. M omega square times R, where R is the radius of the cylinder. Okay. Now, the normal contact force is acting perpendicular to the surfaces in contact, that is N. Also, we know limiting friction is equal to mu S times the normal contact force. Now, for equilibrium, vertical forces must be balanced. That is mg is equal to FL. That is mg is equal to mu times N, where N is m omega square R. You cancel m and you get omega as square root of g divided by mu R. So omega equal to root g divided by mu R within root. That is equal to root of g can be taken as 10. Mu is 0.1. Radius is 1. So root 100, that is 10. So correct answer is B. Ninth one. A particle moving with a velocity v, that is constant velocity. Now that particle is acted upon by three forces. Okay, and all those three forces represented graphically by the triangle PQR. We can see that the arrow marks mentioned in this triangle all forms a cyclic loop. That means this vectors form closed loop. When vectors form closed loop, the resultant will be 0. So sigma f is equal to 0. As net force is 0, acceleration is 0, so velocity remains constant. So it continues to be with the same velocity v without any change in magnitude as well as direction. Next one. Mass attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when wire is at the lowest position. Why? Because at the lowest position, it happens to have more tension. What are the forces? The mass is attached to thin vertical wire and whirled in a vertical circle. When whirled in a vertical circle, what is the tension here? Tension is mg plus mv square by L, where L is the length of the thread. At the same time, when it is at the top, what all are the forces? mv square by L is acting in the upward direction and tension is acting in the downward direction. T plus mg is acting here. So T is equal to mv square by L minus mg. But here T is equal to mg plus mv square by L. So it is more likely to break when it is at the bottom because tension is more when it is at the bottom. I was telling only about uniform circle. Okay, it was moving with constant speed. If the speed is varying, like vertical circle looping the loop, that's another case. Then the speeds may be different. Okay, then also the speed at the bottom will be greatest. Okay, here it is not, may not be that case because it is not mentioned. Okay, it is world with constant speed, then also tension is maximum at the bottom. Okay, so the correct answer is option B. Next one. Velocity time graph of a lift moving downward is a straight line inclined to time axis is 45 degree. So velocity time graph is a straight line. This angle is 45 degree. We know slope of velocity time graph that gives acceleration, that is dv dt, that is equal to slope, that means tan theta, that is equal to tan 45, that is equal to 1. So acceleration is 1 meter per second square. And the lift is accelerating downward with this magnitude. We know the apparent weight when a lift is accelerating downward is m into g minus a. That is, m is capital M here, g can be taken as 10, a is 1, so you get 9m. So the right choice is option B. Next one, 12th one. Body begins to slide down over surface of another when pulled with a force of 10 Newton. Okay, that means when a horizontal force of 10 Newton is applied, the body just begins to move. That means that is the limiting friction. So limiting friction is the minimum horizontal force required to just move a block. Now if we pull with a force of 5 Newton, it doesn't move. That means it is in static equilibrium. But we have applied a force of 5 Newton. So there is a tendency to move. So the block is in the state of impending motion, where there is no motion, but there is a tendency to move. Okay, that time the applied force itself is equal to the static friction because it doesn't move. That's why there is also an equilibrium. Net force must be 0. Applied force is only 5 Newton. Okay, the backward force also should be 5 Newton, which is the static friction. Okay, that means to conclude, within limiting friction, applied force is equal to static friction. Okay, so here correct answer is option C. Next one, 13. It is easier to pull a lawnmower than to push it because pulling reduces normal contact force. Pulling reduces friction. Let me show how it is. You have a block here. Okay, you are pulling it with a force F at an angle theta. Various forces are mg, then normal contact force, then frictional force, then resolving this applied pulling force into rectangular components. If horizontal makes an angle, it makes an angle theta with horizontal, then here one more force component F sin theta. Now here it is clear the normal force is mg minus F sin theta. Now the limiting friction is equal to limiting friction. What is limiting friction? Limiting friction is mu times normal reaction. Mu times normal reaction. So condition for just make it move is F cos theta. The applied force must be greater than or equal to limiting friction. That is mu times normal reaction. Okay, that means F cos theta is greater than or equal to mu n means depends on n. So limiting friction, it depends on n. When n is less, because mg minus F sin theta, when you increase F, mg is a constant. When you increase F, keeping the angle theta constant, what happens? N decreases. When you increase F, keeping theta constant, n decreases. When n decreases, Fl also decreases. So limiting friction is less because it reduces normal reaction. But instead, if you push it, normal force will be mg plus F sin theta. There normal force is more, limiting friction is also more. 14. Two boys are left in the middle of a frictionless floor. One boy, 20 kg, gives a blow lasting 1 millisecond and 100 Newton to the other. He himself will move with the velocity of. Okay, here we have to use impulse momentum theorem. Impulse is equal to change in momentum. What is the impulse? Impulse means F dt divided by mass, because the boy was at rest initially. So the initial momentum is 0. What is the final momentum? M times V. So V equal to F dt by M, impulse by mass. that is direct. F is 100 Newton, time is 1 millisecond, divided by mass is 20. So the correct answer is option D. Next, 15. Body moving with velocity 1 meter per second, force F needed to stop it. That within distance x, speed of the body is 3 meter per second, force needed to stop it within the same distance is. The formula for stopping distance s, we have learned a formula which is the initial kinetic energy divided by retarding force. Initial kinetic energy divided by retarding force. Here stopping distance is a constant. Then mass of the body is also constant. That means retarding force is proportional to speed square. Speed has become 3 times. Speed has become 3 times. So retarding force has become 3 square. That is 9 times. So the right choice is option D. Next one, 16. A fireman wants to slide down a rope. The braking force for the rope is 3/4 of the weight of the man. Minimum acceleration with which fireman should slide down is. We know very clear, if the fireman himself is hanging over the rope will be broken, because rope cannot sustain more than 3/4 of the weight of the man. But he can easily, comfortably slide down with a certain minimum acceleration. The question, what is that? Here we can use the concept of apparent weight, which is the tension of the rope. The tension of the rope when the fireman is sliding down with the minimum acceleration itself acting as the apparent weight. So tension of the rope or apparent weight of the man while accelerating down is m into g minus a. Okay. So you can write F apparent equal to mg into 1 minus a by g. This shortcut can be used directly. F apparent is given 3/4 of mg. Here it is mg into 1 minus a by g. You can cancel these two mg's. So that 1 minus a by g is 3/4. So what is a by g? A by g is equal to 1/4. So a is equal to g by 4. So answer A. 17. Machine gun is mounted on a 2 quintal vehicle on a horizontal smooth road. Friction is negligible. The gun fires 10 bullets per second with velocity 500 meter per second. Mass of each bullet is 10 gram. Acceleration of the vehicle. Acceleration of the recoiling vehicle is equal to net force divided by mass. Net force due to the change in momentum of the bullet is the change in momentum of the bullet by time. What is the change in momentum of the bullet? Mass of the bullet is small m. Velocity of the bullet is small v. Muzzle velocity of the bullet is small v. Okay. Now, n bullets per second as being fired. So change in momentum is nmv. Why? Because initial momentum of bullets were 0. Change in momentum means the final momentum. Okay, in every 1 second, n bullets have been fired. So acceleration will be force by mass by time times mass. That is equal to n is the number of bullets. How many bullets? 10 bullets. Per time is 1 second. Small m is the mass of 1 bullet. That is 10 into 10 power minus 3. V is the velocity of 1 bullet divided by m is the mass of the machine gun. That is 2 quintal. 2 into 100. So this 100 cancels. 5 by 2, 2.5. This will be 10 into 10, 100. Minus 3, you will get minus 1 here. So 2.5, 0.25. So 0.25 meter per second square. That is 25 centimeter per second square. 18. Here, Atwood's machine is the system. Fixed pulley, 2 masses, frictionless, light thread. Acceleration is net force by mass. That is, m1 is greater. So m1g minus m2g by m1 plus m2. That's all. m1 minus m2 by m1 plus m2 into g. You can directly substitute and get answer dog. 19. Rocket is ejecting 50 gram. Rocket, it's a variable mass problem. So accelerating force from Newton's second law, we have to write accelerating force as F is equal to dp by dt, but the velocity is a constant. So mass is not a constant. So we take v dm by dt for that equation. So v is the velocity of ejected fuel with respect to the rocket frame. Velocity is 500. dm dt means rate of loss of mass of rocket. That is 50 gram convert into kilogram per second. So the answer will be beginning with 25, no other options. C. 20. Block of mass m is placed on rough floor of a lift. Coefficient of friction is mu. When the lift is falling freely, what will be the minimum? What will be the force of friction? Okay, when the lift is falling freely, we know the limiting friction is equal to mu times normal contact force. The normal contact force will be 0 because during falling, the acceleration of the floor of the lift and acceleration of the block both are same. That is, earth uses its gravitational force to pull it down, pull both down with same acceleration. That is why the block cannot exert on the floor. Block cannot push on the floor or press on the floor. That's why there is no contact force. N is equal to 0. So limiting friction is 0. That is why the force of friction also will be 0. So the correct answer is option D. None of these. Answer is 0. 21. Two balls of masses 1 kilo and 2 kilo are respectively connected to a spring. Let me draw that relevant picture. These are the two objects connected. Mass 1 kilogram, other mass is 2 kilogram. Now, acceleration, when they pressed and released, lighter ball has an acceleration 2 meter per second square. So lighter one is of 1 kilo. Its acceleration is 2 meter per second square. What is the acceleration of this? We know this spring is used for making a connection between the two balls. So force constant, it is a force constant problem. From Newton's law, F is equal to ma, F constant. So A proportional 1 by m. What happened to mass? Here mass doubled, 1 to 2, mass doubled. When mass got doubled, acceleration is halved. So its acceleration is half of 2 meter per second square, that is 1. So the right choice is option C. Now 22. A rope of mass m is held vertically by fixing the upper end of the rigid support. The tension in the rope at distance x from the rigid support will be tension in the rope at a distance x from the rigid support. We have to carefully read from where to where. This is the rigid support. This is the point P. And this distance is given as x. Total length is L. Total mass is m. So tension means force below. Tension means force below that point or force behind in a general case. Here it is hanging. So force below that point. What is the force below? As the point of support is not accelerating. That is also taken into account. The point of support is fixed. It is unaccelerated. Then only you take the weight below. Weight below. What is the weight of this part? What is the length of this part? That is L minus X. So what is the weight? Tension at the point is the weight below. Weight below is equal to mass below into acceleration. What is mass below? Mass below is mass per unit length into length. Mass per unit length is m by L. Into its own length is L minus X into G. So m by L into L minus X G. Answer is box. Next one. Two trains A and B running in same direction on parallel tracks such that A is faster than B. Packets of equal weights are exchanged between the two. When the faster one, some packet of any mass, any packet, any biscuit pack or food packet, anything of some constant mass is handed over to the neighboring slower train, what happens? There will be a retarding force. There will be a change in momentum associated with the exchange. That change in momentum is affected in two ways to each of these trains. The faster train will be retarded and the slower train will be accelerated, so that the answer is apple. 24. Block of mass 4 kilogram is moving on rough surface with speed 2 meter per second, comes to rest after 2 seconds. Same block kept moving with 3 meter per second. What is the force? We know kinetic friction does not depend on velocity. Kinetic friction independent of velocity. So force of friction remains same in each of these cases. So first case, what is the force of friction? First case, what is the force of friction? Force of friction is equal to mass into retardation. Mass is 4. What is the retardation? Change in velocity divided by time. Change in velocity is 2 because it came to rest. So 4. So 4 Newton is the frictional force. That keeps same because kinetic friction does not depend on velocity. 25th one. Block rests on an inclined plane. Angle of inclination is slowly increased and the block begins to slide down. When the inclined plane makes 30 degree with horizontal, the coefficient of friction between block and the inclined plane is, that we have discussed already, tan 30, because angle of friction is equal to angle of repose. This 30 degree is the angle of repose. So tan 30, 1 by root 3. So answer is dog. An object placed on the surface of a smooth inclined plane of inclination theta, it takes t seconds to reach the bottom. Okay. Let the length of that inclined plane be s. Length of the inclined plane be s. Starting from rest, it comes down and travels over this distance. Then as the acceleration is a constant, we can use kinematic equation. S is equal to ut plus half at square, but u0. So what is that s? Half times a. What is a here? A is g sine theta because there is no friction. It is given frictionless. G sine theta into t square. Okay. Now, it takes time t seconds to reach the bottom. That's written. Now, if the same object is allowed to slide down a rough inclined plane, it takes n times t to reach the bottom. Then also, it reaches the bottom, so the distance traveled is same. Distance traveled earlier is half g sine theta t square. So this time also distance traveled is same. What is the u also 0? What is the distance traveled? Ut plus half at square u0. What is acceleration? Half into. Acceleration is not g sine theta. This time frictional retardation is also there. So g sine theta minus mu k g cos theta, where mu is the coefficient of kinetic friction. G sine theta minus mu g cos theta. That is the acceleration into time square. But this time is n times t. So time square is n square t square. Now you can solve this to get the value of mu. You will get the answer option A. You just substitute this and get the answer. 27. Block of mass m rests on a rough horizontal surface as shown in figure. Coefficient of friction between block and the surface is mu. Force mg acting at an angle theta with the vertical side of the block pulls it. Of the following case, one which the block can be pulled along the surface. Okay, let me denote the various forces here. One of that force is F. Resolve that force into rectangular components, but here this vertical angle is theta. So this becomes F sine theta and this component becomes F cos theta. F cos theta. One more force is acting upward, that is the normal force. Now frictional force is acting backward. Mg is downward vertically. So what is the normal force here? Normal force here, as it is a pulling force, mg minus F cos theta, because the angle made with the vertical this time, mg minus F cos theta. Okay. Now what is the condition for just taking away that F sin theta must be greater than or equal to limiting friction. What is limiting friction? That is mu times normal contact force. What is normal contact force? That is mg minus F cos theta. But it is given F is equal to mg. That is mg sin theta greater than or is equal to mu times mg minus mg cos theta. Okay. Then you can rearrange this by cancelling this mg. You can cancel. That is sin theta greater than or equal to mu minus mu cos theta. Okay. That is sin theta greater than or equal to mu into 1 minus cos theta. 1 minus cos theta can be written as 2 sin square theta by 2. Sin theta can be written as 2 sin theta by 2 cos theta by 2. greater than or equal to mu times 2 into sine square theta by 2. One of this sine theta by 2 you can cancel. Sine theta by 2. Here also one cancel. Okay, this 2 can be cancelled. So that you can get tan theta by 2 greater than or equal to mu. Tan theta by 2 greater than or equal to mu. So the correct answer. Next one, 28. A heavy block of mass m is slowly placed on a conveyor belt. Speed v, coefficient of friction between block and the belt is mu. So through what distance the block slide on the belt? Okay, this is the case. Belt is here. Belt is moving with constant velocity. When the block is just kept, okay, the block slips because block does not have a velocity, equal velocity same as that of the block. Initial velocity of the block is 0. Okay, so, but the belt is moving with a constant velocity. Okay, it is the instant t equal to 0 where the belt was moving with velocity v. Initial velocity of the block is 0. But later on what happens? The block reaches here moving with same velocity as that of the belt. Now block is at rest with respect to the belt. Okay, let the time be t. Okay, through what distance it has moved, that is asking. Okay, now this distance is called the accelerating distance. Accelerating distance s is equal to speed square divided by accelerating distance is same equation can be used that for stopping distance. Speed square u square by 2a. So v square by 2 times a. A here is the acceleration and v is the final velocity. If it was stopping distance, v would have been initial velocity and a would have been retardation. Here it is the accelerating distance. From kinematic equation, v square minus u square equal to 2as. Okay, because initial velocity is 0 with respect to the block. So I have written for block only. S equal to v square by 2a. So where a is the frictional acceleration, that is v square by 2 mu g. Frictional acceleration, a is equal to mu g. That we have learned. Next one. So the correct answer is option D. Next one. A ball of mass 0.15 kilogram dropped from height 10 meter strikes the ground and rebounds to the same height. Magnitude of impulse imparted. As it rebounds to the same height, the collision is elastic, is taken to be elastic because there is no loss of kinetic energy. Okay. So with what speed it was hitting, with the same speed it will be bouncing back. So what is the impulse? Impulse momentum theorem. Once again, this is the question asked in 2021 NEET. So impulse momentum theorem is asked. So impulse is equal to, similar question we have done before. Okay, this was asked in 2021, this year NEET. So impulse is equal to change in momentum. What is the change in momentum this time? Change in momentum is 2 times mv, 2 mv. So 2 mv is the answer. Impulse equal to change in momentum, where v is the velocity with which it hits, v is the velocity with which it bounces back. If one is positive and the other is negative, so v minus minus v is 2v. So 2 mv. So 2 into, what is m? M is 0.15. But v is not given. But it was dropped from some height h. With what velocity it reaches if it is dropped from rest? That is equal to root of 2gh into root of 2 into g10. H is given 10 meter. So this will be 2 into 0.15 is 0.3 multiplied by 100. So 10 root 2. That is 14. 10, 1.4. 10 root 2. Root 2 is 1.4 multiplied by 10. So 10 into 1.4. That is 14. So the close answer is 4.2. Next one, last one. Body of mass m at rest explodes into 3 fragments, 2 of which of masses m by 4 each are thrown off in perpendicular directions with velocities 3 meter per second and 4 meter per second. Initial mass is m. M is the mass. And m by 4 as well as another m by 4. This is the m by 4, another m by 4. Okay. What is the mass of the other one piece? So m by 4 plus m by 4 is m by 2. So this mass will be m by 2. the residual mass, bouncing mass will be m by 2. Okay, so this one is of mass m, this one is of mass m by 2. This is the exploded one, that is already got exploded. Now this is m by 2, m by 4, m by 4. This angle is 90 degree. We have to apply momentum conservation. So what is the momentum before explosion, before momentum after explosion, momentum of each, that is we can use P3 square is equal to P1 square plus P2 square. If this is taken P1, this is taken P2 and this is taken P3. P3 square equal to P1 square plus P2 square, because this is the direction of the resultant momentum. Okay, so P3 is equal to, for resultant momentum to be 0, vector P1 plus vector P2 plus vector P3 equal to 0. For that, vector P3 equal to minus of vector P1 plus P2. What do you mean by that? Modulus of P3 equal to modulus of P1 plus P2 vectors. What is modulus of P3? That is P3. Modulus of P1 plus P2, root of P1 square plus P2 square. Squaring that, you will get this one. So, easy method to apply this directly. What is P3 square? Mass into velocity. Velocity is asked there. Mass into velocity, all square. Mass is m by 2 into velocity, all square. That is equal to, what is P1? Mass into velocity. What is that velocity? 3 square plus another one, 3 by m by 4 into, what is that velocity? 4 all square. That's all. You cancel small letter m here throughout and you get capital V, that you get answer dog. Okay, with that we have completed the discussion of paper 5, Newton's laws or laws of motion, physics part. Okay, thank you.